All right, you guys, so in this case, guys, example 3, we want to go ahead and factor the expression. I have 162 minus a 2x squared. In this case, we've been working with expressions that would be considered difference of squares. Once again, difference of squares can only be used, or the formula for difference of squares can only be used when you have, in this case, a binomial expression that is being subtracted, where both of the terms in this case are perfect squares. So first question you want to go ahead and ask yourself in this case is 162 and a 2x squared a perfect square? If we don't know that from the top of our head, we could actually take out the calculator. Let me go ahead and actually bring out a calculator here. And in this case, all I'm going to do is I'm actually going to go ahead and take the square root of each of the terms. If it gives me a whole number, then it is a perfect square. If it gives me a decimal, then it's not. So square root of 162, in this case, it gives me a decimal, so it's not a perfect square. If I try with the 2 in this case, it's actually also not going to be a perfect square. So if it's not a perfect square in this case, then we want to go ahead and first check then for any GCFs. So my next step is, if it's not a perfect square, let's go ahead and check for any GCFs. And GCF in this case, guys, basically talks about a number that can divide into both the 162 and the negative 2x squared. So in this case, a number that could divide into both of them is actually going to be a 2. So GCF in this case is going to be a 2. We're going to go ahead and factor it out. And in this case, I'm just going to be dividing each of my terms by 2. 162 divided by 2 is going to give us 81. Minus 2x squared divided by 2 in this case is going to give us x squared. All right, now next question in this case for us here is 81 and x squared a perfect square? And once again, we can go ahead and check this, and I'm going to go ahead and do the square root of 81. And in this case, that actually is perfect. And x squared is also a perfect square because x squared is the same thing as saying x times an x. So I want to go ahead and actually rewrite this in the next format. So I still have my GCF in front, and I have parentheses. Now, in this case, guys, a number that you can multiply by itself to give you 81 is going to be a 9. Or like we saw in this case in the square root, it would be a 9. So whatever the square root of this term is, it's actually what's going inside of the parentheses. Minus, in this case, open parentheses, a number or a term that you can multiply by itself to give you x squared is just x. X times x gives you the x squared. So from here, we want to go ahead and actually write our final answer. Our final answer is actually going to consist of these two terms that we have inside of the parentheses. So starting off, we still have the GCF. We always have to include a GCF. If you're going to factor out a GCF from any expression, you need to make sure you include it in your final answer. So we have the 2 in front, and I'm going to go ahead and actually open up 2 binomials, or 2 parentheses here. And in the parentheses, whenever we're doing difference of squares, these binomial expressions are almost identical. The only thing different is that one's positive, one's negative. In this case, my first term, which in this case we found it to be a 9, is actually going to be the first term in our binomial here. And then the x in this case would be the second one. So let's go ahead and write that down. I have 9 plus an x and 9 minus an x. So our answer in this case is 2 times the 9 plus an x times 9 minus an x. And this, you guys, is our final answer.